Hello, friends. Hope you're doing well. It's time for our weekly, and just before we start with the code, I want to ask three things from you. The first one is all the videos that I'm publishing are over 15 minutes. However, the average view rate is between 3 and 5 minutes. Now, I really want to understand what's going on and how to fix that. So please, whether you don't find the content useful, you're not learning a lot, or perhaps you prefer different format, whatever it is, just let me know, whether in the comments or find me out on the internet. So I really want to improve all the content in general to get better for all of us. I understand that it's not interesting to watch somebody coding on the internet, so I got two tips. So the first one is code along with me. As I am doing, do it on your side. That's certainly going to be more entertaining, and I am sure that you'll get better understanding of what I'm doing. And then the second is I don't speak very fast. So if you set the playback speed to 175 for a little bit until your brain gets used to, then get it back to 1.5, that's certainly going to be better because the video goes faster, but it still feels normal. Then the second thing is if you have any ideas that you want to see me doing, like whether it is a problem in hand you have or uh, just anything that comes into mind, whether it's backend, front, like Android, doesn't matter. Um, Throw those ideas at me. I'll try my best to work on them and see how that goes. Now, I first want to finish what we started here with the outside in, doing the whole search functionality. Then I want to do a comparative case study with inside out with the other TDD style to see how that goes, so we can compare. And after that, I can try to work on those ideas. And the last thing is, if you haven't subscribed yet, please do subscribe. That's going to certainly help me a lot. So I think that's going to be it. Now let's jump into coding. So here is where we left off the previous time. That's our acceptance test. So if I run it, it should tell us where to continue. And because I just opened the project, it takes a little time for the first time when I run, but it shouldn't be a big problem. Here we go. And it says that we have to continue at the search repository.search. Now, if we take a look at our sequence diagram that we used to have before, we came up till the boundary level. Now, this repository has to talk with an external world. And I'm thinking that it is a boundary because here I need to do some mapping between what comes from the outside world versus what my system can understand. So I want that translation to happen here. So let's go ahead and see how everything's going to look like. So let's split in two and start off by writing a test for the search repository. And I'll move it on the other side. So I'm going to have them in parallel. Start off by writing a test. So the search repository should return matching results. Let's start off by that one. So I want to make sure that it would return a search state dot, let's import it, yeah. Search state matching results matches, and that's going to be the result. And the result would be when I call a search repository dot search, passing the query, right? And now I want to, so now the search repository, as I said, is going to talk to some other component that will be working with the external world. So I want to do a little setup here. So I would come up with something like a data source. So let's say a search service dot search the query answers matches. So this search service will return matches for the query, and I expect this search repository to wrap that into a result, into a search state and throw it back as a result. Okay, I think now I have to figure out where this data comes from and what it looks like. Let's start off by the query, a local variable, but it's completely irrelevant here. And then I can look at the matches. For some reason, it's not letting me create these matches automatically, so I'm gonna do that manually. It's gonna be a list of, say, 1, 2. It's not very important, these values now for this test, but it's important the type. Because I'm emerging design, I want to know what's the exact type here so that the search repository will return, and the search service, what those types will be. So the search repository will be a property here that I'll be initializing in the before. Come on. Okay. And finally, the search service is also going to be a property. But the search service actually is going to be an in-memory search service, because that's what I want to start off with. So first, I'm going to have an in-memory search service, and then I'll think about different implementations later on. So let's create a class. And I'll throw it in the search package. It's fine for now. I'll move it on the other side. However, I'm working with a search repository for now. And this is going to be a mock. And because we are working with mocks, I have to extend here with mock extension. All right. And of course, the search service doesn't have a search function. Let's create it and let it throw an exception, as we were doing so far. And now the search service.search should return. So here, the highlight here tells me that it does not return the type that I am setting it up. So I have to make it return the correct type. Cool. Now everything seems fine, except there is no relation between the search repository and the search service. So I have to inject here the search service and add it as a parameter on the search repository here. And that's going to be a private vol. Exactly. And now if I run the test, I would expect the acceptance test to fail because I'm injecting additional dependency to the search repository that was not there before. And exactly, I have that failure here. So let's go ahead and create a real instance in memory search service for the acceptance test and run again my initial test that return matching results. Now it should reach out, but it will fail because it's not implemented. Exactly. And in fact, if I delete the line and run, it should tell me that basically I'm expecting a type and the type that is returned is different. So here it is. I'm expecting matching results, but it returns a unit. Now I know that the test fails for the right reason. Let's go ahead. In fact, it's not still the right reason because now I have different type here. So it's sort of the right reason. So here I should search state. I should return search state. And now here, if I return let's say, search state dot matching results empty list and run, now it should fail for the right reason. It's really important to watch a test failing for the right reason, because that's how we know that if, like, later on, if a behavior changes in the code, we are going to have a failing test for that. That's why it is very important to watch it fail and make sure it fails for the right reason. So now I am expecting matching results, but it returns different thing. I mean, it returns a matching result, but inside it returns different value. So let's go ahead and fix that. So essentially, I here have to call like matches is the search service dot search query, and here put the matches. And if I run, now it would pass. So essentially, this line here, the call to the search service is very important. So here in the test, this setup here, so I'm not verifying if the line is called, but rather it is sort of implicit. It's not explicit, but implicitly I'm expecting the line to be called. Okay, now it works. Let's check that in. The search repository uses a search service, or actually performs a search using a search service. Cool. Now let's go ahead and write another test that would be return searching error. I have to handle errors too. So I want to make sure that the search state dot search error is the result, and the result would be a search repository dot search query, and the query would be again irrelevant. As search error, I have to create the search error, and that's going to be additional object. Let's move it on the right side. So yeah, additional object in the search state that would represent errors. So essentially, this search error would be, I'm thinking of it as a state that would represent errors like, let's say, the backend. If I make a call to a backend, it returns something between 400 and 500. So those are the error states that I want to cover with a search error. Okay, and now I have to do additional setup here that every search service dot search query throws, say, a bad search exception. Let's create a class, and I'm gonna put that into an exception package, and that's gonna be a runtime exception, let's say, which is unchecked. That's good to go. I'm gonna run and watch it fail. Now, the reason why I'm coming up with custom exceptions is that I don't want to depend on low-level exceptions. So for example, if I make a real call to an API, or if I make a real call to database, those would, for example, throw an IO exception or a SQL exception or that kind of things. But I don't want to mess with such a low-level exceptions in my system. I just want this boundary to do that translation for me. So that's why I'm coming up with custom exceptions. So later on, if I, for example, change some of that low-level implementation that might throw different exception, I wouldn't have to, change the internals of my system. I'll just have to do the changes in write the new integration, and that's going to be it. That will do the translation. So here, in order to fix, I need to wrap this into a try catch, and the catch would be bad search exception, and I would return a search state search error. And now let's run. Awesome. And in fact, here I can leave the return before the try. Run again. Good. Let's check that in. The search repository handles a bad search exception. Cool. And then I'm thinking that I also have to cover the offline state. So if I try to make a search but I'm offline, let's say return offline error. And again, I want to make sure that a search state offline is returned equals the result, which is a call to a search repository dot search query. Then a query would be relevant range arg.assert. Then the offline would be yet additional object inside the search state that would represent the offline. And now run, it should fail. Sort of annoying to wait this long for the tests to run, but that's due. I mean, it's definitely influenced by the fact that we use mocks. And we are going to see in the comparative case study that it goes faster when we use no mocks, actually. Catch bad search exception. So here we have an offline exception. Oops, sorry. Yeah, so here I have to do the setup that says that every search service dot search query throws out of internet exception. So let's create a new class into the exception package, which is also going to be a runtime exception. And that one is good to go. And now I run the test. Yeah, that was a little distraction because I was trying to explain something. Yeah, so I could have, it's better if I write the mocks myself, but in Kotlin, when I have a concrete type, I cannot mock it out easily. So that's why I'm using library, and the library is actually doing the mock for me, and that takes time. So back to here, return offline error. Now I can write the catch. Now I have the actual exception being thrown. And here is the bad search exception, I would say offline, or actually out of internet exception. And then it would be search state dot offline, run. Good. And now let's check this in. The search repository handles an out of internet exception. Cool. Now, one thing that I'm observing here is that my search repository depends on a concrete implementation here. So it injects concrete implementation. I don't like that. I want to extract an interface for this in-memory search service so I can depend here on an abstraction. And then the in-memory search service will be just one implementation. And then I may come up with different implementations for, let's say, a remote search service, local search service, whatever. So this is the search service class. Let's go ahead and do a extract interface refactoring. And I will say extract separate file. And the new file will be called just search service. And that's going to be an interface in the production package that will have an abstract function called search. Let's do that refactoring. And now if I open this search service, exactly, it's an interface that has a search function. That's all it has. And my in-memory search service is just an implementation that for now it has nothing. It's not implemented yet, which is fine. That's what I want. And then my search repository here should depend on a search service rather than the concrete in-memory implementation. Now I'm going to run the tests to make sure that I didn't break anything, which I shouldn't because I was doing automated refactorings, which are always safer than manual ones. Great. Now I would check this in. Extracted an interface for the search service. And the last thing I want to do in this test is to remove this duplication of the query because it's the same in all three tests. So I think it's going to make the tests a bit better and cleaner, especially because the query is not very relevant in these tests. So I think that they're having only the relevant information inside here. And they run, so I would check that in too. And that would be removed duplication in test. Okay, and now I'll go back to my acceptance test and run it. It should tell me where to continue. And it says I have to continue in the in-memory search service. But of course, because it's going to take time to do the contract tests now, and that's a topic that I want to cover in the following week episode. I'm going to leave that for the next video. And I think for this one, this one is enough. So I think here, if we go back to the whole plan, I think we covered the design here. Essentially, In the previous 3 episodes, we've seen how we are leveraging the mocks in order to come up with design, how the design emerges as we go with the outside in approach, of course, by using mocks. And the last thing that we'll have to cover is the contract tests, and essentially we'll get the whole wiring and the whole feature working. That's going to happen probably in the next video. And until then, I can just thank you for the attention. Thank you so much. As always, let me know what you think in the comments, and I'll catch you in the next one. Bye-bye.